any other property on it, then we don't have to do anything. But if we are deleting a node which is black, then the black height of that path, or number of black nodes in that path will be reduced. Then we will be calling this red flag mix-up program, and that red flag we fix up, like we have seen red flag in delete fix-up, insert fix-up we have already seen. So there we have taken Z. What was Z there? In insertion. That was the new node insert here. And the color of that node we made red. And then we have seen the property two consecutive reds are not red. If its parent is not red, then no problem. If its parent is red, then we are doing some rotations around it. Cases from here, or the case when we have our left side, similarly when we have the right side, and case here we are calling this arbitrary delete fix-up on X. What is X? X is the child of the node which has been deleted. X is the child of the node which has been deleted. So, say X is this node, and then its parent is the Dx, and here also now here we have taken three cases for Pz. Pz is left child, then Pz is right child is middle. Here we will be taking three cases for X. When four cases there will be here. When X is left child, then we will consider its right child, that is something of XW. One. Second, before entering into the loop, we will check one condition. This is the function. Then there we are checking this condition. While X is not equal to root and color X is equal to black. Because what we have done, we have some node was there by which has been deleted. The node was there in the tree y which has been deleted, and we will be calling this function only in the situation when the color of y is black. If the node which has been deleted, if its color is black, only then we are calling. If its color is red, then no problem. So then we are calling this function on X, or we fix up X. X is child of the deleted node, and then we are checking this condition. If X is root, because it may happen the deleted node initially it's root itself or something, then we are calling on that and X becomes the root. Then I don't have to do anything. Because after division, if X becomes the root, then W will not be present even, or W will be present. Suppose when I delete some node and its child becomes the new root, it means what? I have deleted root.
That W is not present.
I have deleted root itself. And the node which I am deleting, I am sure that is having only one child.
Yes, sir.
ठीक है? W तो present हो ही नहीं सकता जब वो नोड डिलीट किया और एक्स रूट
लेफ्ट वाला रूट बना तो डब्ल्यू
ठीक है, एक्स रूट बन गया तो एंड रूट में व्हाट वी आर सेइंग देन माय that property which was being disturbed because of deletion of a black node, that will change number of black nodes on all the paths from that side. So my black height is not disturbed. Disturbed in the sense black height has been reduced. Black height has reduced, but it is reduced on all the paths. It is reduced on all the paths. And second condition, if color of X is red, the color of X is red, so like this was Px and this was Y and this was X. So if I have deleted Y which was black and color of X is red and X is the only child of Y, Y is not having two children, then what I can do, I can pass the color of Y to X, make X black. Then also my problem is solved.
Yes.
One black I have deleted, one more black I have added, problem is solved. So in that case also I don't have to do much. The only problem will come if I have deleted Y node which was black and X is also black. Then I have to do something else. And in this process of the while loop, now hypothetically we assume, on this point listen carefully, hypothetically we will assume that this color of the node Y which was deleted and which was Y, that has been passed to X. X is already black and that also has been passed to X. Indirectly, hypothetically, I am assuming X is doubly black. X is
doubly black.
Doubly black. So, if hypothetically we are giving a definition that the node which I am calling X in this tree, that is effectively doubly black, then my everything is balanced. But only my problem is X is doubly black and this extra black which is in the X, that has to be adjusted. That has to be adjusted.
सर ये समझ में नहीं आया सर, एक्स्ट्रा ब्लैक
डब्ल्यू ब्लैक है ना,
इसमें क्या हुआ कि इसमें जैसा यहाँ पर कोई ट्री है, यहाँ पर होता है, अब ये नोड मैंने डिलीट कर दिया, अब ये ब्लैक था, अब इसके डिलीशन करने से क्या हुआ कि इस पाथ में ब्लैक कम हो गया, ठीक है। अब इसका जो ब्लैक कम हुआ था जो बाकी पाथ में इसके कंपैरिजन में ज़्यादा है, तो दैट एक्स्ट्रा we are assuming that has been assigned to X. So hypothetically I am saying my tree is still balanced in terms of black. If I consider जब X का काउंट लेंगे, वैसे तो एक ब्लैक नोड का एक काउंट लेते हैं, बट X के केस में हम we are considering at दो काउंट्स. Then my tree is balanced. That's what is the meaning of it. But that is hypothetical assumption. ठीक है? As such we don't have any provision of storing two blacks in there. और उसमें ये है कि अगर X रेड है तो वो एडजस्ट अपने आप हो जाएगा डब्ल्यू ब्लैक, और अगर X ब्लैक है तो देन आई हैव टू डू एडजस्ट. नाउ we'll see the next case. If X is equal to left of Px, means if X is left child of its parent, if X is left child of its parent, then we will be considering 4 cases, and similarly 4 cases will be there when X is right. But those cases are just symmetric. Symmetric means we are putting left to right करने, right to left करना. Other things are same. So then we W is equal to sibling of x. W is sibling of x. And now we will be seeing 4 cases. Out of these 4 cases, one case is considered under the category when the color of W is red, and 3 cases are considered under the category when color of W is black. Clear? So first case we are considering when color of W is red. So this will be the one case, and remaining 3 cases we will be considering under the category when color of W is
black.
black. So if color of W is red, then but I am making a claim my tree will be at least this of this type. Because X is black. X is black. Color of W is red. Then obviously this also will be black, because there cannot be 2 consecutive red nodes. And X is doubly black. X is doubly black. It means W will have at least
One black.
2 children which are internal nodes and are black. Because when X is doubly black, now see this point carefully, when X is doubly black, X may be terminal node also, X may be nil-T also, X may be external node, nil-T. But because X is doubly black, means one extra black is there in X. So W will also have
2 children.
2 children which are not terminal node, which are not nil-T. Well, W cannot be leaf node. W cannot be
Leaf
leaf node. And W has both its paths. And both the paths will be having, both will be black. Even they cannot be red also, because W is red. 2 consecutive red also not allowed. Okay? So these 2 blacks internal nodes will be the children of W, if W is red. And what we will do simply, then this is P, this is Q. We will rotate this tree around Px, and rotation will be left. Rotation will be left. And after left rotation, how the tree will look like? W will go up. Then this P will be here. P3, and X is black, X is doubly black, T is black, then U is black, and now I have to maintain my black height also, then balanced. So on this path to strike T6, how many blacks are there? 1 and 2 plus blacks in T6. So from that point of view, have to swap the color of these two. This was earlier black, this was red. Now this will be made black
Red.
and this will be
Red.
and then we will call this as our new W. Instead of this, now we are calling, because W is supposed to be the sibling of X. W is supposed to be the sibling of X. So what are the steps we have taken? Left rotate around PX, make the color of PX as red, make the color of W as, well, the first you do, make the color of, actually steps for instead of taken, color of W will be black, color of PX will be red, and then we are doing left rotate around Px, and then you call x is equal to what was your sorry, W is equal to this P. P is what? Right of so by doing these steps, what have we done? If you see now, black white is restored, but only X is still doubly black. X is still doubly black, and this is my new W. And what I have changed, earlier my condition was W was red. Now W is
Black.
black. So case 1 में what we have done, why we have entered in case 1, the color of W is red. And what we have done in case 1? Made the color of W to black after rotation and changing some color. Okay? So if we are in case 1, then by doing this process we have entered to the subsequent situation. That was case 2, 3 or 4, which was supposed to be entered. Color of W is black. Color of W is so now we have to see these cases where color of W is black. So that will be after this part, after this if. Okay? And I should not put even here else. Why I should not put here else? Because even it was red. By doing this I have made it black. By doing this I have made it black. So without putting if condition, now this case 1 has been handled. It's not handled. This case 1 has been translated to subsequent cases 2, 3, 4, which otherwise also we would have entered if color of W was black. Okay? So subsequent part now we will be handling the situation where color of W is black. So now what we are looking at the situation, that is Px, X and W, which is black. X is also black. X is also black. Px का color can be anything. Px color can be anything. Because if W is red, then Px has to be black. But if W is black, Px can be black or Px can be red. We don't have to worry. Now here one thing is there, because X is again doubly black. So now we are seeing one situation, that is case 2. Case 2 says W is black and both its children are also black. Both its children are also case 2 में we are considering W is black and both its children are also
Black.
black. And this is the simplest case, but here what we will be doing is we simply shifting our problem to one step up. One step up means what we will do is make both these. Now this has red and this will be
black,
made
Sir, black.
black,
black. करने की वजह इसको I will call my new x. Okay, we don't know what is the color of Px. We don't know what is the color of Px. ठीक है?
सर इसे तो ब्लैक होना ही है.
Px can be black, Px can be red also.
सर रेड.
लेकिन अगर W रेड है तो सर
W अगर black है
अगर तो अभी तो रेड है.
सर अभी रेड कर दिया.
हैं?
अब तो आपने रेड कर दिया.
कहाँ किया रेड? W को रेड किया है ना.
तो अब तो रूट ब्लैक.
और मैंने Px को x कह दिया.
एक्स.
मतलब
कोई भी करना.
x कहने का मतलब ये है कि अगर Px पहले रेड था तो अब ब्लैक हो जाएगा. ऑलरेडी ब्लैक है तो W ब्लैक हो जाएगा. तो W ब्लैक में किसको बोल रहा हूँ? x को. W ब्लैक किसको बोल रहा हूँ?
एक्स को.
क्लियर? तो केस 2 में what are we doing that if left x sorry left of W is equal to black and right of W is also equal to black, then what are we doing? Color of W is equal to red and x is equal to
PX.
x is equal to Px. So effectively we have shifted our problem
One step up.
to one step up. Earlier x was W black, this was black. Now what I have done basically I have extracted black from here, added here, one extra black from here, added here, and now this I am calling my x. This I am calling my x. Okay? And so case 2 में the problem is just shifted one step up. ठीक है? And it will again go back to this loop, which loop is saying the color of x is black. Then we have to enter into this loop to solve this W black problem. If color of x is red, then I will simply exit from this loop and force the color of x to black. मतलब ठीक है? So I should not change color of Px here. I will simply say x is equal to x is equal to Px. So this was case 2. Now case 3. Case 3 में we take case 2, 3, 4. All the three cases are we are handling the situation when color of W is black. Case 1 में we have handled when color of W was red. So after rotating we have made W black. Case 2 में we have considered when W is black, both its children are black. So we have shifted the problem one step up.
ठीक है.
Case 3 में
Color of W is equal to black.
W को black है 3 में भी. Then we are saying the right child of W is
Red.
black. Case 3 में we are saying that is if that is case 3 if color of right W is equal to black. Obviously right W is black and both are not black because that we have already handled the situation. If both are black, that situation is already there. It means then this is
Right. Red.
red. Then this is
Red.
red. And in that case, we will be rotating the tree around this point, W. And say this is my P, this is Q. And what we will do,
Left or left.
Px is unchanged,
Left or left.
X. This P will be now go up, W will go down, and Q will be here. Say these are say E1, E2, E3, E4, E5, E6. So E1, E2 will remain as it is. E3, E4, E5, and exchange the colors. Make this as black, or this as black, and this as red, and this will be my new W. This will be my new W. So W is always sibling of X. Now, by doing this rotation, this was case 2. What was case 2?
Black.
W is black, and its right child is
Black.
black. Now, what is the right child of W?
Red.
Red. And in fact, this is my case 4 also. This is my case 4 also, when color of right child of W is red. Color of right child of W is red. So, indirectly what we have done, case 3 has been translated to case 4. And if by default we are in case 4, no problem. Okay? So, what we have to do, if color of W is right of W is black, then we will be doing this rotation. And by this rotation and color change, we have made right child of W as red. And in case W right child by default is red, then I don't have to do anything. Well, we are already in case 4. So, case 1 पे तो we have made W black. Case 1 को सरल. Case 2 में we have shifted problem one step up. And case 3 में, by making this rotation, we have entered into case 4. And final adjustment we are doing now in case 4. And what is general situation of case 4? W is black and its right child is red. Its right child is red. Left may be red, may be black. Left may be right, may be black. After doing that adjustment case 4 में what we are now looking, W is black and it's this which we are calling P, this is Q, this is C dash. So the color is not known. It may be red, it may be black. Now in this situation, we will be rotating this tree around Px, and 3 will be rotated left. That is the final situation. After this rotation, if we rotate left around this Px, then what will be this situation? And before doing this rotation, even we have to do some color changes also. And those color changes what we are doing. This color of W will be equal to color of Px, because this is a situation X is doubly black, W is black. Color of Px also is not known to us. It may be red, it may be black. Color of this also is not known, but color of right of W is red. ठीक है? So what we did, color of W is equal to color of Px. In W में the same color will be assigned instead of Px. This is C, so this will be C. This is the C dash, and then what we are doing, color of Px will force to black. Make this as black. And then we are doing left rotate around Px. So after doing left rotation around Px, W will go up. This was Px, so this is made black now. This is X, P1, P2, Q, P will go to this is originally what was the color here? C. This was black. And one more color change we should have to do it. That was color of right W is equal to black. This also should be changed. Now, if you compare these two subtrays, what was the problem in this subtray? X is doubly black. This is the problem. This is the problem. Now, what is the situation in this tree? Do we require X to be doubly black, or now we are satisfied if it is singly black also? Check all the paths. How many black nodes are there in this path? So that is C. Calculate. After this I am calculating. X में दो blacks हैं and rest is blacks हैं T1. Right? इस तरह X में दो blacks हैं, rest is black है T2. What about this? एक ब्लैक, दो ब्लैक, ब्लैक से तीन, वन ब्लैक, टू ब्लैक, ब्लैक in now number of black nodes in T3 path. एक ब्लैक, इसका जो भी कलर है, इसके बाद ब्लैक से यहाँ पर क्या है? वन ब्लैक, whatever is the color of C1, remaining black in T3. One black, remaining black in T4. Then what about this T5 part? One black, remaining black in T5. Depending upon what is the color of this. Same is here. Depending on by the color of this, then one black, remaining black in P5. Then one black, remaining black in P6. So that way what we have seen, now black nodes on all the paths are maintained. Only thing X which was doubly black, now it is, we are having two blacks, so we don't require X to be doubly black. So if we don't require X to be doubly black, so there I will simply call in this condition, that was case 4, X is equal to root 3. Because after this we have to go to this loop and we have to terminate in the, after doing this case 4 rotation I should have terminated. And to force termination what I have done, I have made X is equal to root. And if X is equal to root, so we will have this solution. And after all this case 1, 2, 3, 4 जो भी है solve okay, in the end then symmetrically opposite both cases also will be there, and last statement will be making color X is equal to black. Color X is equal to black. Whether X is root or X is red. We will terminate from the loop under two conditions, whether X is red or X is root. So we are forcing color of X to be black. So quickly go through, and I am just repeating the steps. When X is the child of the node which has been deleted, and if its color is red and it is not root, then it means, and the node which we have deleted is was also black, only then we will be calling these functions. Because node we have deleted black, it means we have removed some black node on that path. But the node which we have deleted can have one child only and say that child is X. If no child also, then that child will be nil-tail. That child will be nil-tail. So it may happen that node we have deleted is having no child. Then in that case X will be nil-tail. So whatever is the situation, one X black node has been removed. So we have to do the adjustment. So we will be considering this X and we will be picking up its sibling. We will be picking up its sibling. Even if X is nil-tail, the sibling W will exist. Why it will exist? Because X ka parent has been deleted which was black. X parent has been deleted which was black. Therefore Px must be having X sibling, that is W. Right? Now if color of W is red, then we are performing, then W should have, now I think you should be convinced why its black sibling also should exist. अगर black sibling नहीं है, red sibling है, तो उसके children होंगे दो black. ठीक है? अब black nodes are there, and then we will be rotating the tree around Px, and we will be getting new W which is black. Which is
Black.
So case 1 is resolved there. Now case 2, 3, 4, all the three cases W is black. But they are three sub cases. How we are divided? In first case W is black and both its children are black. Then we are shifting problem one step up. Then we are shifting problem
One step up.
one step
Up.
Then we are having the situation if W is black but its right child is black, it means left is not black. If both are black, we have shifted one step up. If right is black, then by rotating around W right and swapping the color with left child which was red, that was made black, and W was made red, and rotate right. We had translated our problem to the other situation which is saying the right child of W is
Black.
red Right side of W is red, which is we are having on the board. When right side of W is red, left का color we don't know, that is C dash. PX color also we don't know, that is C. Then we will be changing these colors. PX को black करेंगे, color of W will be color of PX, and color of right side of W will be made black, and then we will rotate the tree left around PX. And this modified tree में our problem of doubly black is solved. Now we need not keep X doubly black. So then force termination we are doing by making X is equal to root. X is equal
Yes.
to but if you observe carefully whether insertion we have seen or deletion we have seen, all this process may case 1, 2, 3 whenever we are handling. Either we are shifting problem one level up or we are doing rotation and stopping. If we shift one level up, maximum how much we can shift? Log n. Height of the tree is log n. So what we are saying, insertion we can do in log n time if my tree is balanced, and then this adjustment also we can do in log n time. Okay? So this way we can on a red flag tree we can insert or delete or search a node in log n.
Login time.
So any question in this regard? So red flag tree over. Now next topic.
Next topic क्या है इसके बाद?
Subnet side के next.
Anjit syllabus?
Hashing किया.